Hi everybody, welcome back to Intermediate Algebra. Today we're in section 7.4 and we're finally going to be putting together a lot of what we've learned in sections 7.1, 2, and 3. We're going to bring it all together to be able to add and subtract rational expressions today. So we're going to talk about adding rational expressions that have the same denominator, and then we'll add rational expressions that have different denominators, and that's going to require us to use what we learned in section 7.3. And then we'll talk about subtracting rational expressions, which will use a lot of the same skills that we've already developed in the first part of the section. So it's all going to come together right here in this section. Let's go ahead and get started. Okay, we'll start off adding rational expressions that have the same denominator. So, as always, we compare this to what we already know about regular fractions. Remember, when we add regular fractions, we combine the numerators and the denominators stay the same. We'll see an example of that in just a minute. Rational expressions work exactly the same way. So you can see it here. If you have P over Q and R over Q, and of course Q can't equal 0, but you have the same denominators here, then when you add these two expressions together, the top is going to be P plus R, and the bottom is going to stay the same. You already know that from adding regular fractions. In other words, to add rational expressions with the same denominator, you will add the numerators and keep the same denominator. Okay, here we go with example 1. So it just says add, and then it reminds us, write each answer in lowest terms. You always have to remember to check if your answer can be reduced when you're adding and subtracting fractions. So let's start with 4 over 9 plus 2 over 9. And as you know, when you're adding fractions, the denominators have to be the same, and you just add the tops and the denominator stays the same. So 4 plus 2 is 6, and the denominator stays the same. Now notice that we have ended up here with two numbers that can both be divided by 3, so we have to do that. So we'll write 6 as 3 times 2 and 9 as 3 times 3. The 3's reduce, and that just leaves us with a final answer of 2 over 3. Let's try that here. So notice that we have the same denominator. That means we can go ahead and combine the tops together. So 3x over x plus 1 plus 3 over x plus 1 means we have 3x plus 3 all over that same denominator. Now notice that there's a GCF in the top here. So we need to undistribute or factor out that 3. So if we factor out the GCF of 3, that leaves us with x plus 1 in the parentheses. 3 times x gives us that term, 3 times 1 gives us that term. So this is the factoring. Notice now that we have like factors in top and bottom, so we can cancel out the x plus 1's, and that just leaves us with 3. Okay, now let's talk about how to add rational expressions when the denominators are different. It's really not any different from adding rational numbers that don't contain variables. It's very much the same steps, so here they are. First, you'll need to find the LCD, and we learned how to do that in the last section. Then you'll need to write each rational expression as an equivalent rational expression, and we also did that at the end of the last section. And your new denominator, of course, will be your LCD. And then, whatever you have to multiply by to get that target denominator, you're going to multiply top and bottom by that same factor, and then you'll have common denominators and you'll be able to combine like terms in the numerator. If you can simplify at the end, you should do it. And you may have to factor before you can know for sure if simplifying is possible. So always be on the lookout for that. If you can factor, then go ahead and do it to see if simplifying is possible. Okay, here we go. Practicing again with just regular numbers first, then with a monomial, and then we'll get to some that are binomials. And then we'll get to work with some denominators that are binomials and trinomials. Okay, so we have 1/12 plus 7/15. So first, let's find that common denominator. 12 breaks down into 4 times 3, And if we need to, we can break down the 4, but let's see what happens with the 15. 15 breaks down into 3 times 5. Okay, there's not any 4s or 2s here, so we don't need to break down that 4. Let's go ahead and build our LCD. So first of all, we have a 3 here and a 3 here, so we're going to need a 3 in our LCD. And then we have a 4 here, so we need a 4, and we have a 5, so we need a 5 in our list. And multiplying this all together, 3 times 4 is 12, and 12 times 5 is 60. So 60 is our common denominator, or our target denominator. So let's look at it like this. 1/12 plus 7/15 is going to need to be transformed into something over 60 plus something over 60. See, because that's our common denominator. So what would I have to multiply by 12 to get 60? Well, of course, I need to multiply it by 5. So that means I need to multiply top and bottom by 5. So the new top number there is 5. For 7/15, well, what would I have to multiply by 15 to get 60? So 15 times 4 is 60. That means I need to multiply the bottom by 4. That means I need to also multiply the top by 4. So 7/15 becomes 28 over 60. Now that the two denominators are the same, I can combine terms in the top. 5 plus 28 is 33, so I have 33 over 60. Now this is the answer, but it's not in simplest form, because notice that both of these numbers can be divided by 3. So I need to factor these down and cancel out the like factors. 33 is 3 times 11. 60 is 3 times 20. The 3's reduce, and we're left with 11 over 20. So this is the basic procedure that we're going to be following in all the remaining examples. So here we have, in part B, 2 over 3y plus 1 over 4y. So first let's find our common denominator. So there's no factoring to do here because 3 is prime and 4 is 2 times 2, but that doesn't share any factors with the 3. So there's no need to break anything down. We'll just build our common denominator. The LCD needs to contain a 3, and it needs to contain a 4, and there's one y here and one y here, so I only need one y in my LCD. So we end up with a common denominator of 12y. Okay, now let's get our fractions and figure out what we need in order to reach this target denominator. If my first denominator is 3y, what do I need to multiply by in order to end up with a 12y? So I need to multiply by 4, yes. So if I multiply by 4 in the bottom, I need to also do that in the top. And that means the new top number for the first fraction is 8. And on the second fraction, I start with 4y and I want to end up with 12y. So I need to multiply this denominator by 3. And that means I also need to multiply the top by 3. So 1 times 3 is 3. Now I have the denominators the same. So now I can say 8 plus 3 is 11. So I have 11 over 12y. And notice that 11 over 12 cannot be simplified. So this is the end result for this example. Okay, here in example 3, as promised, we have some denominators that are made of binomials. And it says add, write each answer in lowest terms. So before we can add, we need to get a common denominator. And in order to do that, we have to factor this difference of squares. So first of all, x squared minus 1 gets factored into x minus 1 times x plus 1. Okay, now I have my second fraction, and this denominator cannot be factored, so this fraction did not change. Okay, now we have to build our LCD. So the common denominator needs to contain an x minus 1, and it also needs to contain an x plus 1, because I have one of those here and one here, so I need one in my LCD. So this is our common denominator. This first fraction already has the common denominator, but the second fraction is missing the x minus 1 factor. So I need to multiply that x minus 1 into the bottom and therefore into the top as well. Now remember, I have told you before there's no requirement or expectation that we multiply the denominator factors back together, and that's true. But in order to get like terms combined in the top, we are going to have to distribute this -1. So what we'll do is we'll put this numerator here, and then we'll distribute this -1 and put those terms here. So we have this plus here. Now -1 times x is going to make -x. And -1 times -1 is going to make +1. And finally, we can combine like terms. Of course, the denominator does not change. Now 2x plus -x makes +1x, and we have +1 here. And now you can see we have an x plus 1 in the top and an x plus 1 in the bottom, so those will reduce. There are no factors left in the top except for the invisible 1 that's always there. So now we have 1 in the top and x minus 1 in the denominator. And don't try to cancel here because this 1 is not a factor. So this will not reduce. This is our final result. Let's try that again on example 4. So we're just going to do several examples together, and we're going to keep doing this until you've had a chance to get the hang of it. So this one is not really different from the last one. It's just different expressions. And we have trinomials in the denominators here, so we'll need to factor these two trinomials. So first of all, we'll have 2x over x squared plus 5x plus 6, which gets factored into two binomials. X squared becomes x times x. Last times last is positive, so the signs here need to be the same. They both need to be the same as the middle term, so two plus signs. And then 6 is going to break down into 3 times 2. So that way outer plus inner adds up to that middle term that we want. Okay, for the second fraction, our denominator is x squared plus 2x minus 3. So that's going to factor into two binomials, x times x. The signs in the binomials need to be different. And last times last is 3, so I need 3 times 1. I'm going to put the 3 with the plus sign and the 1 with the minus so that outer plus inner will add up to positive 2x. Okay, now I'm ready to build my common denominator. So in our LCD, we have an x plus 3 here and an x plus 3 here. So we need an x plus 3 in our common denominator. We have an x plus 2 here, so we need one of those. We have an x minus 1 here, so we need one of those. And this is our common denominator. Now, just as kind of a safety rail for you, I promise you that none of the problems in this assignment will have more than 3 factors in the common denominator. So if you end up with a list of 4 factors in your common denominator, you'll know something is wrong, and you can go back and fix it. 3 is the limit. So now we need to figure out what's missing from each factor, and we need to multiply that missing factor into the fraction. So compare this denominator to the common denominator. What's missing? Well, this one needs an x minus 1, so we'll put that there, but then we also have to put it in the top. And this one has x plus 3 and x minus 1, but it needs an x plus 2. So we'll put that there, but that means we also have to put it in the top. And notice that I had to put the existing numerator in parentheses to show that the x plus 2 is going to get multiplied by everything that was already there. Okay, now the denominator factors will not get multiplied together. We will leave those in factored form. But we do need to distribute here, and we need to use the FOIL method here in order to see what the terms are to get our final answer. So distributing the 2x here, 2x times x is 2x squared. 2x times minus 1 is minus 2x. Over here, using the FOIL method, first times first is x squared. Outer times outer is 2x. And inner times inner is 1x. And last times last is 2. And now we're ready to combine our like terms. Again, the denominator does not change. And let's go ahead and add here in the top. 2x squared plus 1x squared is 3x squared. With the x terms, negative 2x plus 1x gives us plus 1x. And then our only constant is plus 2. And so this is it. Now, if this would factor, we would try to factor it and see if we could cancel any of these factors from the denominator. But this top is a trinomial that does not factor into two binomials, so we can stop here, and this will be our final result for example 4. Okay, here is example 5. Notice the instructions say add, write each answer in lowest terms. So we have y over y minus 2 plus 8 over 2 minus y. And the first thing we notice is that these really aren't different denominators. They are different, but they are so closely related, they are opposite denominators. So we would not want to create an LCD that has y minus 2 times 2 minus y, because that would cause us to do a lot of extra work. We want to take advantage of the fact that 2 minus y is the opposite of y minus 2. So let's take that 2 minus y, and let's factor out a negative 1, which is going to let us change the order of the subtraction. And so what's going to happen is that this second denominator is now going to be y minus 2, but this negative that's in front here is going to move out here and change this plus to a minus. So we're going to rewrite our problem as y over y minus 2 minus 8 over y minus 2. You see that? By changing the order of the subtraction here, it created an extra negative which got put out here and changed the plus to a minus. And so now, to combine these fractions, all we have to do is put y minus 8 over this one denominator. And that's it. This cannot be reduced. The y's cannot be canceled because the y's are not factors of the top or the bottom. So in order to cancel, the y would have to be a factor in both places, and it's not. So this cannot be reduced. 8 over 2 cannot be reduced because, again, these are not factors, they are terms. And so this is it. That's the end of that one. But I want you to see here that changing the order of the subtraction cost us a negative, which changed our plus to a minus. You can always do that. You can always change the order of subtraction by putting that negative out here as a sign change. Okay, now we're going to talk about subtraction. So to subtract rational expressions, it's the same steps we used for adding, except that you'll need to get rid of that minus sign by distributing it through the numerator. You will distribute the minus sign through the numerator, and then you will combine like terms and keep the same denominator. It's a lot like when you learn to subtract polynomials. Remember, you had to distribute the negative first. That's what we're doing here. So let's get an example. So here we have 2m over m minus 1 minus m plus 3 over m minus 1. So what I want you to notice is that the minus applies to both of these terms. That's why we have to distribute it. So what I always want you to do is rewrite these as addition problems, but distribute the minus sign. So your first fraction is going to stay the same, then you're going to change minus to plus, and you're going to distribute that minus here. So this is going to become negative m minus 3, and it's over m minus 1. Okay, now let's combine like terms. 2m plus negative m is 1m, and then we have negative 3 here. So we end up with m minus 3 over that same denominator, m minus 1, and this cannot be reduced, so this one is finished. Okay, now let's work on a subtraction problem where we have different denominators. So the instructions again say subtract, write the answer in lowest terms. We have 9 over x minus 2 minus 3 over x. Well, the first thing we see is that the denominators are different, so we are going to require a common denominator here. Let's go ahead and build our LCD. So we're going to need an x minus 2, and we're going to need an x. Now, when we copy our problem down before we work on the LCD, let's go ahead and change this to addition form. So instead of minus 3 over x, it's going to become plus negative 3 over x. So we'll have 9 over x minus 2 plus negative 3 over x. See how we just changed from subtraction form to addition form. And now let's work on our common denominator. This denominator is x minus 2. In order to make it look like this, we need to multiply it by x. So we'll multiply top and bottom by x. Notice the parentheses. The parentheses here are required. They are very necessary to show that the whole denominator is getting multiplied by x. And on the second fraction, we have an x in the denominator. We need an x minus 2. So we'll multiply top and bottom by x minus 2. Okay, now when we combine everything over one common denominator, we'll have in the top 9x plus negative 3x plus positive 6, because negative 3 times x makes negative 3x, and negative 3 times negative 2 makes positive 6. And so now it's time to combine like terms in the top. 9x minus 3x is 6x, and then we have our plus 6 here. The bottom is still the same. Notice that we could factor out a GCF of 6. If we did that, the top would then be 6 times x plus 1, and that would be okay, but doing the factoring would not help us reduce, so it's not required, and we are just going to leave this result right here, just like this. Okay, here we have example 8, and it says subtract, write the answer in lowest terms. So here I have 3x over x minus 5 minus 2x minus 25 over 5 minus x. Notice again that our two denominators are not really different, they're just opposites. So remember the trick that we used last time? Well, it's not really a trick, it's more kind of a shortcut. We can change the order of subtraction, but it's going to cost us a minus sign, which comes out here and changes this sign. So our problem is going to end up being 3x over x minus 5. And then we're going to change the order of subtraction here, which is going to change this minus to a plus. And then we're going to have 2x minus 25 over x minus 5. So again, changing the order of subtraction, change this sign from minus to plus. Now it's not a subtraction problem, now it's an addition problem. So on this one, I end up not having to distribute the minus after all. So let's go ahead and combine like terms over this common denominator. 3x plus 2x is going to be 5x, and then we have this minus 25. Now, I do see a GCF of 5 here in the top, and I know that if I factor out that 5, in parentheses, I'm going to have x minus 5. And I want to go ahead and do that because the x minus 5 now in the top will cancel with the x minus 5 in the bottom, and we'll just be left with the final result of 5. And now example 9. So again it says subtract, write the answer in lowest terms. So these two denominators are clearly different, and we're going to need to build an LCD. But before we can build that, we'll have to get these factored. So let's go ahead, and while we're doing that, we'll change the minus to a plus and put that minus here. So it's going to be 6x over this factoring. So x squared is going to be x times x, and the signs need to be the same. They both need to be minus, and it's going to have to be 1 times 1. Now let's double check that outer plus inner adds up to negative 2x. It does, so we're in good shape here. Now we'll change minus to plus, and we'll put that negative here in front of the 1. If we had multiple terms here, we'd change all the signs here, but we just have that one term. So minus 1 becomes plus negative 1, and this difference of squares gets factored into x minus 1 times x plus 1. Now let's build our common denominator. So I have x minus 1, I have it twice here and only once here, so I need to put down x minus 1 twice, and then I need an x plus 1, and that will do it. So I have x minus 1, x minus 1, x plus 1. Now I've just recopied that here and left room for myself to put in the missing factors. So if the first one has x minus 1 times x minus 1, it needs a factor of x plus 1 so it can have this same denominator. So I'll multiply x plus 1 into the top and the bottom. This one already has an x minus 1 and an x plus 1. It needs an additional x minus 1 So I'll put that in both top and bottom. Okay, now on the next line, the denominator will not change. It will remain in this factored form, but we'll need to distribute this 6x here, and we'll need to distribute this minus 1 here in order to get the numerators combined. So 6x times x is 6x squared. 6x times 1 is 6x. And now distributing this minus 1, negative 1 times x is minus x. Negative 1 times negative 1 is positive 1. And the denominator is those same 3 factors. And let's combine our like terms. So in the top, 6x squared is just that. 6x minus 1x is 5x, and then we have our plus 1 over that same denominator again. And now notice that this top is a trinomial that cannot be factored, and so this is the end result for example 9. And finally, example 10. This is the last one that we'll do together. So again, it says subtract. Here we have q over q squared minus 4q minus 5 minus 3 over 2q squared minus 13q plus 15. And again, before we can subtract, we need common denominators, so we'll have to get these two denominators factored. The q squared minus 4q minus 5 is a trinomial that's going to factor into two binomials. Q squared is q times q. The signs need to be different in order for the last times last to make a negative, and then 5 has got to be 5 times 1. So I'm going to have the 5 with the minus sign and the 1 with the plus sign, so that outer plus inner will add up to negative 4q. Now, because this is minus, I'm going to change minus to plus and put the negative over here with that term in the top. And let's go ahead and factor the denominator. So this trinomial is going to factor into two binomials. 2q squared is 2q times 1q. The signs need to be the same, both negative. And 15 is going to factor into 3 times 5. Let's put the 5 here and the 3 here so that outer plus inner will add up to negative 10q minus 3q, which is negative 13q. That's what we wanted. Okay, now we'll build our common denominator. We need a q plus 1. We need a q minus 5. So we have q minus 5 here and here, so we need 1 in our common denominator. And we need a 2q minus 3. So now we have these three factors. Remember, I promised you your common denominators will never have more than 3 factors. So we feel like we're on track here. And let's go ahead and figure out what we need to multiply by in order to achieve this common denominator. So for the first denominator, the factor that's missing is 2q minus 3. So we'll multiply that into top and bottom. And for the second denominator, the factor that's missing is q plus 1. So we'll multiply that into the top and the bottom. Okay, now let's distribute the q here and the negative 3 here. The denominator will stay the same. So distributing in the top, q times 2q is 2q squared. Q times negative 3 is negative 3q. Distributing the negative 3 here. Negative 3 times q is negative 3q. Negative 3 times 1 is negative 3. The denominator is those same 3 factors in whatever order, doesn't matter. And then let's combine like terms. We have 1q squared term, that stays the same. Then we have negative 3q minus 3q, so that's negative 6q. And then that one constant term stays the same, and our denominator stays the same. And that's it. Now again, note that if this top could be factored, I would have to do that and see if I could reduce anything, but this one cannot. So this is our final result on example 10. Now I know that this section is complicated and ticky, and there are a lot of details, there are a lot of places to make mistakes. This is where you have to really pay attention and really dig in. Use this as an opportunity to build up your skills, learning to pay attention to signs, pay attention to simplifying. It takes a lot of practice. There are a lot of things to keep in mind, and you're not going to be able to get them all in your head without doing some practice so that some things become second nature. Just don't give up. Practice, don't procrastinate. Do all your studying in little chunks And that way your skills will develop over time and you'll be able to see it each time you come back to work on your math. You'll see that you've improved a little bit. But if you try to do it all in one big session, you're going to get overwhelmed and you're going to get tired and you're not going to see the progress that you want to see. So don't procrastinate, study in little chunks, ask questions when you need to, and you can do this. See you next time.